Hello students, these are the notes for Wednesday's class, and we're going to be looking a little bit deeper into the equations of lines. We spent time yesterday working on slope and briefly mentioned y-intercept. Today we're going to be working on how to calculate those two values so that we may plug them in and actually finish off the equations of lines. Our objective for today is the student will discover the process and applications of slope-intercept form. Again, these are the notes for Wednesday's class. I believe the date for Wednesday will be October the 16th, I believe is correct. So copy your objective and your date. Press pause anytime you need more time to write something down, and press play when you're ready to move on. Okay, now any line that can be graphed has an equation that describes how to graph it. And we spent a good bit of time this year trying to learn how to read those equations, to know what to expect from a graph simply by reading the equation. Okay, now the most common format for the equation of a line is the format that we should be used to by now. It's slope-intercept form. It's not the only format that's out there, and we will get to a couple of other formats here in the next week or so. Okay, but slope-intercept form should be something that we are readily familiar with, and slope-intercept form is y equals mx plus b. Now, of course, m and b are constants that need to be plugged into the equation so that we can understand what it is that the line is supposed to do. So m is your slope value of your line, which we talked about yesterday, and b is the y-intercept value of the line. We just mentioned the y-intercept yesterday. There's not really much to understand about it. It doesn't do a whole lot except fix the graph to the y-axis, so it's not much of a mystery. Okay, but m is going to change according to what the line is doing or how it's behaving, and b is going to change according to where the line is attached to the y-axis. Okay, now what that's going to mean is that x and y are part of the equation of the line, and with only a couple of exceptions, you will always have x and y in your equation of your lines. Okay, and for those of you that have been participating with me at the door coming into the classroom, what have I been saying every time you see the card that says linear equation? Okay, it is an equation that has x to the first and y to the first. Okay, we need the x and we need the y in order to make the equation linear. Okay, so what that's going to mean is that the line does whatever it does based solely upon the values of m and b. Okay, now before we get into the equation here, there are exactly two exceptions that go along with slope-intercept form, and you can probably already guess what they are. You've probably had this explained to you before. Okay, but the first exception to the slope-intercept form, and it's not really an exception, it's more of a variation, is a horizontal line. Now, as we mentioned yesterday, horizontal lines have slope values of 0. That means that the line does not rise, but it will run. That puts a 0 as the numerator of your slope, and as we should know by now, a fraction that has a 0 as a numerator has an overall value of 0. That means the coefficient of x in y equals mx plus b is going to be 0. There will be 0 x's in the equation. Well, if there are 0 x's in the equation, are they even going to write any x's down? No, they won't. Okay, there are no w's in the equation. They don't write those down. There's no pink flamingos in the equation, so they don't write those down either. So if there are 0 x's, your equation will not have an x. So the equation of a horizontal line is always y equals, and then you need a number that tells the line where to cross the y-axis. So in the case over on the right-hand side of your screen, that equation is y equals -4. The flip side of that actually causes the slope-intercept form great problems. Vertical lines. Well, as we talked yesterday, a vertical line, of course, rises just fine, but it will not run. That makes your slope fraction have a denominator that is equal to 0. So the slope fraction is undefined there. Okay? Well, we cannot take an undefined value and plug it into an equation without wrecking the equation. So the issue becomes, all right, what's slope-intercept form going to do? Well, the answer is slope-intercept form is not going to do anything. We cannot plug that value in. Okay, so our equation of a vertical line is going to be different. Now, just like the horizontal line above was just a y equals a number, and it told the line where to cross the y-axis, our equation of a vertical line is going to be x equals a number, and that number will tell the line where to cross the x-axis. So the equation of a vertical line is always x equals wherever the line crosses the x-axis. And in the case over on the right, it crosses at 3, so the equation is x equals 3. An easy way to remember that is that the horizontal line only crosses the y-axis, so it will only have a y variable in it. And the vertical line only crosses the x-axis, so it will only have an x variable in it. Okay, now let's see if we can't start building some of these equations here. What is the equation of a line that has a slope of 2/3 and crosses the y-axis at -4? Now, there's about 1,000 different ways that they can present us with information about a line or ask us about assembling the equation of a line, but it's all going to boil back down to the same two questions for us over and over and over again. And those two questions are, what is the slope of the line, and what is the y-intercept of the line? Okay, and once we can achieve these two answers, then we can write our equation. Well, let's look at the problem in this case. Did they give us the slope value of the line? Yes, they did. They came right out and they handed it to us as 2/3. Okay, what about the y-intercept? Did they provide us with the y-intercept? Yes, again, they handed it to us. It crosses the y-axis at -4. Okay, this is obviously not a challenging problem. We're just getting our feet wet here. So we're going to take, now that we have our slope value and our y-intercept value, we're going to take them and we're going to plug them into the slope-intercept form. So yes, just like yesterday, I do want you to write down the equation before you plug into it, y equals mx plus b, and then you can plug in your m, which is 2/3, and your b, which is -4, which will give us an equation of y equals 2/3 x minus 4. Another question, what is the equation of a line that hits the origin and has a rate of change of -1/2? Now, this problem does not do anything more difficult to us than the last question did, but this is more of the level of the language that we can probably expect in a class like Algebra 2 as compared to a class like pre-algebra or Algebra 1, which was the way, the kind of the level that the last question was written on. Okay, but the same two questions arise for us. We need to know the slope, we need to know the y-intercept. Did they hand us the slope this time? Yes, they did. They handed it to us just like they did on the last problem. The only difference is they used a little bit more complicated language. Okay, this time they did not call slope slope. They called it rate of change. And the rate of change is -1/2. So that's going to be our m value. How about the y-intercept? Do we know what b is? Yes, we do. Once again, they did give it to us, but they used a little bit more technical language, and they hid it by saying, or hid it because they said that the line crosses the origin. Well, of course, the origin is on the y-axis as well, so our line crosses the y-axis at 0. So once again, we're looking at our slope-intercept form, y equals mx plus b. We have everything that we need. Slope is -1/2, b is 0. Okay, but I have a question. If the b value is 0, are they really going to write down plus 0 at the end of this equation? No, they're not. Okay, just like a lot of other things, if it doesn't change the value of the equation, they're probably not going to write it down. So if you ever see an equation that looks like this one, y equals some value of x, and there's nothing attached to the end of it, well, that simply means there is no vertical shift. The graph crosses through the origin. Okay, what is the equation of a line that passes through points 2, 3, and 4, 5, and hits the y-axis at 1? Well, this is getting to be more on the level of Algebra 2. Okay, the wording of the question is more complicated. They're explaining it in a little bit tougher language. Okay, but once again, it does not change our chore here. We have to figure out what m is. We have to figure out what b is. Okay, look at the problem. This time, did they give us the slope value? This time they did not. but they did give us 2 points on the line. And as we know from yesterday's lesson, all we need in order to calculate the slope value of any line is 2 points on the line. So we have that. We will be able to figure out what the slope is. How about the y-intercept? Did they give us the y-intercept this time? Yes, they did. They identified it as said that it hits the y-axis at +1, so we do know the slope value, or the y-intercept value. Okay, now back to the slope. Okay, same math as we did yesterday. We're going to follow the same procedures as we did yesterday. We're going to take our 2 points and we're going to label them x1, y1, and x2, y2. And yes, I do still expect you to actually label your points x1, y1, and x2, y2. And we're going to need our slope formula. And yes, I do still expect you to write your slope formula down. y2 minus y1 over x2 minus x1. I want all the information in one place before we begin plugging anything in. Okay, so now we're going to plug in our values. y2 is 5, y1 is 3, x2 is 4, and x1 is 2. As always, watch out for your subtraction and your negative signs and things like that. Let's simplify our slope. The numerator is 5 minus 3. That's going to be a 2. The denominator is 4 minus 2. That's also going to be a 2. So we have a 2 over 2, which reduces nicely to 1. Okay, can we write our equation of our line now? Yes, we can. The only thing that we were missing was the slope value. Now we have it. So write down your slope-intercept form, y equals mx plus b, and you can assemble your equation, y equals 1x plus 1. And in all reality, they don't even have to write that slope value down. They could just write y equals x plus 1. Okay, one more example. What is the equation of a line that passes through points -3, 1 and 0, -3? The same questions are going to arise for us. What is the slope? What is the y-intercept? Okay, this time have a look at the problem. Did they give us the slope value? This time they did not, but we do know that we have 2 points on the line. We can calculate it using those 2 points. How about the y-intercept? Did they give us the y-intercept this time? I imagine a bunch of people are thinking, no, there's no y-intercept provided for us, but look a little closer at the second ordered pair, 0, -3. Where is it that this point is at? 0, -3 is on the negative y-axis. So they actually did give us the y-axis intercept, but they disguised it rather cleverly, and you can expect some little twists like that. Okay, they did give us our b value. It is at -3. So the only thing we need to do is calculate slope, and we know how to do that. We'll take our 2 points and we'll label them x1, y1, and x2, y2. We will write down our formula, y2 minus y1 over x2 minus x1. Then we will plug in our values. y2 this time is a -3, y1 is a +1, x2 is 0, and x1 is -3. So when you plug into the slope formula, we should have something that looks like that. In the numerator, -3 minus 1 is -4, and in the denominator, 0 minus negative, that makes a +3. 0 plus 3 is 3. So we have a -4/3 slope. Is that enough information for us to write our equation? Yes, it is. Okay, we can plug in our slope, we can plug in our y-intercept, so the equation will be y equals -4/3 x minus 3. The real challenge of writing equations of lines is going to arise when this happens. What is the equation of a line that passes through points 1, -4 and 4, -3? When we look at the questions, what is the slope value? Did they give it to us? The answer is no. And then when we look at the problem and say, what is the y-intercept value? Did they give it to us? The answer is once again, no. Okay, it leaves us in a spot where we do not know much about this line, and this is where the challenge is going to be. This is kind of the worst case scenario for writing an equation of a line. So that's where we're going to begin Wednesday's class. I will actually walk you through the rest of these examples together. I believe it's just a little bit too difficult for us to do over the notes. over the computer. So I will see you in class on Wednesday, and we will answer a few questions that are along these lines. I appreciate you finding time to do your notes. I'll see you in class.